Hello friends, I suppose all of you are fine and doing good with your studies. Whatever videos I have uploaded, I suppose you have understood and accordingly you have been doing the problems that I have explained. Today again a topic that I have chosen both which is present in class 11 as well as 12, that is relations and functions. I suppose you are not forgetting to share my videos or my channel with your friends, and those who are new to this channel or this video, please give your comments and press on the notification uh, icon and subscribe my channel, and whatever suggestions you have, please do give it in the comment box. So without wasting much of your time, let us move on to the topic. Please see the video in total, and whatever you understand accordingly, you try to solve the exercises or the problems of the book. So relation and function was the topic that I was speaking about. In class 11, what you have studied is relations, ordered pairs, real valued relations, and domain, codomain, and range. Now, let me little bit revise very soon. What is ordered pair? Suppose we have a non-empty set A. Then all the pairs of between A and A is known as ordered pairs. For example, if we have A as 1 and 2, then 1 1, 1 2, 2 1, and 2 2. This is the ordered pair that I think you will recall. Now, what is, if I take a subset of this ordered pair, that becomes a relation. If R is a subset of the set of ordered pairs, then this becomes a relation. I think you are recalling what you have studied. Now, what is function? Function is a subset of relation, or function is a type of relation. Now, suppose we have two non-empty sets X and Y. They are non-empty sets. Then, suppose we have, this is X, this is Y. Here we have X1, X2, X3. Here we have Y1, Y2, Y3. So I have taken two definite sets or finite sets, not definite, they're finite sets. Now, it may be, if it is a relation from X to Y, that every element of X may not relate to somebody in Y. Or it may also happen that one element of X has two different pairs. That means X1 is related to Y1 as well as X1 is related to Y2. These two conditions are not supposed to be there for a relation to be a function. What it is? That means every element of X should have a pair in Y. Every element in X should have a pair in Y. Not this one, and say this one. And this is not allowed. That is, X1 is having pair with Y1, X1 is having pair with Y2. If it is there, then it does not become a function. That means they should be distinct. So for every X belonging to X, there exists Y belonging to Y. And all the ordered pairs in the function cannot have the first component same. That means we cannot have in the function like this X1, Y1 and then X1, Y2. This is not possible. So let me review. A relation is a function from x to y if every element of x has a pair in y and all the ordered pairs in the function do not have the first component same. This is the definition of function. Now, what is domain, what is codomain, and what is range? This is very confusing for some of the students. Please understand the concept. I think it will be very clear to you. Then I shall do this, give you some examples also, so how to find out the domain and range of a given function. Now, when we were speaking about two sets x and y, the first set from where x is related to y, that set is known as the domain. And the second set where it is related to, that is known as the codomain. Now, it may so happen that, suppose we had one more element, say y4, where y4 has no relation or nobody is related to y4 from x. Then only these three elements are related, x1, y1, y2 and y3. These three elements, y1, y2, y3, they are known as the range of the function. That means for the values of x, what are the corresponding values of y? They become the range of the function. Okay? I think you have understood the three top points or the three terms: domain, codomain and range. Now, I shall tell you how to find out the domain or range for a real valued function. Now this is our function fx is equal to x minus 3 by 2x plus 1. We have to find both the domain and range of this function. Now let me tell you, this is related only with real valued function. We are interested about finding out the domain and range for a real valued function. Now, since it is a real valued function, the function should give real values for the values of x and y. We are not dealing with the complex values. So, those should be the values of x for this function, for which the function does not give any infinite value. This is the first condition. Second condition is the function should give always real values. Means we should not get negative square root of a negative number. Now this function will be a finite value if the denominator is not equal to 0. Is it okay? So domain of f we have to find. So domain of f should be what? What should be the values of x? That is we are trying to find. So that will be possible only if 2x plus 1 is not equal to 0. So x should be not equal to minus 1 by 2. 1 is transposed and divided by 2. So except minus half, we can put any value of x from the real numbers. So domain of f should be all real numbers except the number minus half. That's why except means minus we are putting. So we have got the domain. So domain of f should be real numbers deleted minus half. I think it is clear. Now what is y? What is range? So let this be y equal to x minus 3 by 2x plus 1, or 2xy plus y is equal to x minus 3. We will make x as the subject. So 2xy minus x is equal to minus 3 minus y. or x is common, 2y minus 1 is equal to minus 3 plus y, or x is equal to minus 3 plus y divided by 2y minus 1. So let us visualize this figure. This was x, this was y. So these are the values of the domain, these are the values of the range. Means what should be these values? So we should visualize in the same way that for what values of y we do not get any infinite number of x. So that is possible only when 2y minus 1 is not equal to 0 or y is not equal to half. So range of f becomes all real numbers except the number half. So this is how we find out the domain of this function and the range of the function. Let us see the next example. Let us see this example. Fx is equal to 1 minus mod of x minus 2. Now, modulus function, we know always this modulus of a number will be absolute value, so it will be always positive. Now, domain of the function. What I told in the previous example, that we should choose those values of x which give a real number. Fx will give a real number and it is finite. Now what we observe here, for all values of x belonging to the real number, any real number you put, it will always give a real number. There is no chance of getting any complex number, or we can never get any infinite number. For all values of x belonging to R, fx is finite and real. Therefore, domain of the function is very simple, that is all real numbers. Clear? Now, what is the range? Let this be equal to y. We know that modulus of a function is always greater than 0. We know modulus of x is greater than 0. Equal to also we can say if x is 0. So mod of x minus 2 is greater than equal to 0. And minus of x minus 2, mod of x minus 2 is less than equal to 0. So 1 minus mod of x minus 2 is less than equal to 1. If you are adding 1 on both sides, and this is what? This is y. Because we have considered this as y is less than equal to 1. Means all the values from 1 and lesser than that. So range of f is what? 1 and from minus infinity. Less than 1 means 0, minus 1, minus 2, minus 3, minus 4 and up to minus infinity. So range is minus infinity to 1. I think it is clear. Let us see some more examples. Let us see this particular function. Fx is equal to root over 16 minus x square. Now, we should be very careful when there is square root. 16 minus x square, if it becomes negative, then the function will become complex. So, for this function to be real valued, inside square root whatever we have, that should be more than or equal to 0. So, for fx to be real valued, 16 minus x square should be greater than equal to 0, or 4 minus x and 4 plus x should be greater than equal to 0. Therefore, x belongs to minus 4 to plus 4. We know from the properties of inequality, if a minus x into b plus x is greater than equal to 0, a minus x into a plus x is greater than equal to 0, then x belongs to minus a to plus a. So this is the domain we have got. So domain of f is minus 4 to plus 4. Now we have to calculate the range. Let y is equal to under root of 16 minus x square. Then y square is 16 minus x square, or y square minus 16 is equal to minus x square, or x square is equal to 16 minus y square. Now we know that square of any real number is always positive. So 16 minus y square is greater than equal to 0, or 4 minus y, 4 plus y is greater than equal to 0. So y belongs to, again, minus 4 to plus 4. But the square root of a real number is always positive. So y is greater than 0. Therefore, range of f is 0 to 4. So this is the range and this is the domain. Let us see this trigonometric function. Y is fx is equal to 2 minus 3 cos x. We have to find the domain and range. We know cos x is values lie between minus 1 to plus 1. So the domain of cos x, the range of cos x is from minus 1 to plus 1, and cos x is never infinite. So this function fx will never become infinite, whatever value, real value of x we put. So the domain of fx is very simple. It is all real numbers. The function is defined for all values, all real values of x. Now the question arises, how to find out the range for this function? As I told you, cos x values are in between minus 1 and plus 1. I think no doubt in that. Now, if I multiply with minus 3 throughout the inequality, we get 3 greater than, okay, but let us multiply with 3. Then it will be easy for us to understand. 3 cos x less than equal to 3. Okay. Now, I multiply with minus 1. Then this becomes 3 greater than equal to minus 3 cos x greater than equal to minus 3. First I multiplied with 3, then I multiplied with minus 1. Then the inequality changes. Now we add 2 on both sides. Adding 2, we get 2 plus 3 greater than equal to 2 minus 3 cos x greater than equal to 2 minus 3. Clear? So 2 plus 3 is 5 greater than equal to, this is what, this is fx, or y, this is greater than equal to minus 1. So fx values will be in between minus 1 to 5. So the range of f is nothing but all the real values from minus 1 to 5. Well, this was a series of examples that I could search for all of you to understand the concept of domain and range, or how to find out the domain and range for a given real valued function. Please don't forget to go through the concept which is given in your book also, and then correlate what I have spoken, and then try to do each and every problem of the exercise. Anywhere, any type of difficulty you face, please comment in the comment box. Any type of help you require, please let me know, so that in my coming videos I can upload more examples, more problems, more concepts which will surely help you. I hope all of you are doing well. Stay well, study well, and do well in your exams. Good luck. Thank you. See you again. Bye bye.